Welcome to the third part in the series where I show you how to communicate with the Pi and Pico W with BLE. In this part I show you how to read values from the Pico's internal temperature sensor and the temperature of the CPU on the Pi. Let's get started. First, note that we will be doing this using picozero on the Pico and GPIO0 on the Pi. Now, of course, here is picozero. Now, I haven't heard any updates from this. Last I heard that they were updating it to the next version. It's currently in beta, as you can see here, at this moment. So, I had to copy the Python file straight to my Pico. So let me show you here. So you'll see right here I actually had to copy it. And the reason I had to copy it right here was because it wouldn't let me install the library automatically. Also, I will be using Fahrenheit instead of Celsius as I live in the US, but feel free to use Celsius if you want. And I'll show you what I mean with the code when we get to the setup now. So yes, now with Pico Temp I have it set up to Fahrenheit. Now again, you can use Celsius if you want, and of course I should make this clear that I also did the same thing as well for this code, so we'll talk more about this code as well. Also, I have the Pi 4 set up here, and also I have everything, and I also have the code ready to go. So first, let's talk about the code that we're going to run. So we'll start with the Pico first. Now we'll start with Pico Temp. So the only thing I changed here for Pico Temp is that again I imported the Pico Temp sensor, and then I got the temperature here. Then I did the formula where I multiplied the temperature by 9/5 at 32. That's the formula to convert. Again, if you don't want to do this, you can just ignore this line here. Other than that, it's pretty much the same code as before, as you can see here. The only difference here is when we send the data, we send the temperature, and then of course I added F because I wanted to. You don't have to do this, but this is just what I wanted to add. And that's for the temperature. For dual temp, the only thing that I changed here is I added a receive data, so I will be receiving the temperature as well. Let's get to the Pi. So I will get this here. Let me get the screen sharing, so I'm going to get here. So with Pi receive, this is pretty much the same code as I used in the beginning. There's nothing different here, it's all the same. This will be when I receive data from the Pico, and when I want to send data, this will be the code here. So I imported the CPU temperature module, and you can see it right here. Then I got the temperature by doing this. Then of course I decided to round by 2 digits. And then of course I have all the usual things. The only thing I did here was I sent the data, but everything else is still the same. Nothing else has changed. So the only thing that's changed is I am sending the temperature. Make sure you use this, because I didn't, and it just sent me this statement. So make sure to add F to your print statements in this case. Other than that, that's really it. So we're going to get started in the next section. So we're going to break this down into 2 demos. So first we'll run the Pico sending data to the Pi, and then we'll run the Pico sending data to the Pi and vice versa. So let's get to it. Let's go. So the first thing I want to run is Pico Temp. So I'll run this quickly. Let me go to the Pi very quickly. So I'm going to go to the terminal, So I'll do Python 3 pi receive. So we'll move this here so you guys can see. So it's now connected. And you can see that the temperature is 88 degrees Fahrenheit. So it's actually not bad. If you live outside of the US, 88 degrees for the Pico is actually not bad. It's actually a lot cooler than I normally would expect, because in some cases I'd expect this maybe to be 95 or even 96 degrees, but 88 degrees is not bad. So there you go. And yes, the LED is blinking. In fact, I even got the other LED to blink as well. So again, I'll make this code available on GitHub. So let me just exit out of this. All right, and I will stop this code. Okay, so that's it for this demo. Let's move on quickly to the next one. Right, let's move on to the next one. We're going to use this one. I forgot to mention, I probably should have mentioned here that the blink task that I have that I showed here is for blinking the LED, as you'll see here. Forgot to mention this. On both codes I have this, so I have global connected because connected is false. Forgot to mention this, so I'll mention this before we start. And then of course we toggle it's true. So while this is true, it'll toggle, the value will toggle, and then we'll set it to not toggle, so it will blink on and off. The blink will be 1000 milliseconds, which is a second, if it's connected, else it'll be 250 milliseconds, and then we'll await, and then the sleep MS will be blink, so in this case it's 1000 milliseconds. So if it's blinking 1 second, that means it's connected. If it's blinking 250 milliseconds, it means it's not connected. And of course I made sure to also add this to my create task here. But that's it. I kind of forgot to tell you guys, so my apologies on that. But anyways, let's get the other code running. So run dual temp next. And make sure to run the same. So I will run pi temp send, just to make sure that I'm running the same code. Okay, got it running. And you can see that the Pi is currently running at a crispy 111.75 degrees Fahrenheit. So, actually not bad. Okay, the Pico did slightly increase to 95, which is expected because, again, I'm running code using Bluetooth, so I did expect the temperature to go up. Now, on my Pi 4, I have a heatsink and fan running, so if I had removed the fan, it probably would have gone up a little bit. But overall, you can see that we are both reading the temperatures from both the Pi to the Pico and from the Pico to the Pi. So let me clear this demo. So I'm going to exit out of this, and I'm also going to exit out of this. And that's it for this demo. That's it for part 3 of the series, but stay tuned next time where we will read values from a potentiometer and control the brightness of an LED using that potentiometer. See you next time.